Hello everyone. In this video, we shall discuss increasing and decreasing functions and as well as the intercepts of a function. So in this lesson, we will determine the intervals in which the given graph of a function is increasing or decreasing. And we shall inspect the graph and use the interval notations to identify the intervals where the graph is increasing or decreasing. And at the last part of this discussion, we shall describe how to get the intercepts of a given function. So for increasing and decreasing function, let us start with the following example. Let us consider the graph of this function. So this graph is a line. So we shall inspect the graph from left to right, and we have to look at the values along the x-axis. So the leftmost part of the x-axis is negative infinity, while the rightmost part is positive infinity, since this axis is extending indefinitely in both left side and right side. So as we can see, from left to right, the graph is continuously increasing from the negative infinity up to positive infinity. So this means that the graph is increasing in the interval from negative infinity up to positive infinity. And since this graph is continuously increasing, then there's no interval in which the graph is decreasing. Now, second, let's consider this line. So this line from left to right is actually continuously decreasing. So again, the x-axis is from negative infinity to positive infinity. And since the graph is continuously decreasing from left to right, then there's no interval in which the graph is increasing. Now, for the intervals where the graph is decreasing, we should write negative infinity up to positive infinity. Now, next is we consider the following graph, and again, the x-axis will be labeled from negative infinity up to positive infinity. But if we look at the graph from left to right, the graph is decreasing until this point. And this point has x coordinate equal to 0. So this means that the graph is decreasing from negative infinity up to x is equal to 0. So that means we have to write it as negative infinity, comma 0. And we shall use parentheses, the two parentheses for after 0. And then the graph is increasing from this point up to positive infinity. So which means that the interval where the graph is increasing is from 0 up to positive infinity. And then let's have another graph here. So if from left to right, so this graph is increasing up to this point, and then decreasing up to this point, and then it will be continuously increasing. So if we get the intervals where the function is increasing, we start with negative infinity until 0. So we write it as parenthesis negative infinity, comma 0, close parenthesis. And then union, the other interval where the graph is increasing is from x equals 2 going to positive infinity. So we shall write it as parenthesis 2, comma, positive infinity. And then the interval where the graph is decreasing is from x equals 0 up to x is equal to 2. So we shall write it as parenthesis 0, comma 2, close parenthesis. Now the formal definition of the intervals where the function is increasing and decreasing is as follows. So given a function y is equal to f of x that is defined on the interval of x from a up to b, we say that the function f of x is increasing on the given interval if x sub 1 is less than or equal to x sub 2, implies that the function value of x sub 1 is less than or equal to the function value of x sub 2 for all x sub 1 and x sub 2 in the interval from A up to B. Now, for the definition of decreasing, we see that the function f is decreasing on the given interval if x sub 1 is less than or equal to x sub 2, implies that the function value of x sub 1 is greater than or equal to the function value of x sub 2 for all x sub 1 and x sub 2 in the interval from A up to B. So graphically, if we want to show the definition of increasing function, as we can see on the x-axis, we have here the point x sub 1 comma f of x sub 1, and then we have a second point on the line, which is x sub 2 comma f of x sub 2. So as we can see here that the x sub 1 is to the left side of x sub 2, which means that x sub 1 is less than or equal to x sub 2. And in this case, f of x sub 1 is lower than f of x sub 2 along the y-axis. So this tells us that whenever x1 is less than or equal to x2, it implies that the function value of x1 is less than or equal to the function value of x sub 2. So since the definition of increasing function is satisfied, then we can say that this is an increasing function. Now for decreasing function, again, since x sub 1 is to the left side of x sub 2, we say that x sub 1 is less than or equal to x sub 2. And then here in the y-axis, we see that f of x sub 1 is above f of x sub 2. So that's why f of x sub 1 is greater than f of x sub 2. So which implies that this function is a decreasing function. And then finally, we shall describe how to get the intercepts of a function. But what are intercepts? And the intercepts of a given function are the points in which the graph would intersect the x-axis and the y-axis. So for example, if this is the y-axis and this is the x-axis, and let's say that we have a graph of a function. Now this point here is the point where the graph of the function hits the x-axis. So this means that this is our x-intercept. Now the coordinates of the x-intercept in general will be a comma 0. So this means that whenever we're looking for the x-intercept, we need to set the value of y to be 0. And then at this point here, since this point is the point of intersection of the function with the y-axis, then this is the y-intercept. And in general, it is denoted by 0 comma b. In this case, in the y-intercept, we see that the value of x is equal to 0. So mathematically, whenever we're given with a function y equals f of x, the y-intercept 0 comma b is obtained by evaluating f of 0. So which means that whenever we're given with a function, we substitute the value of 0 to every occurrence of x in the function. And then the x-intercept a comma 0 is obtained by solving the equation f of x equals 0. So for example, if we have the function, let's say 2x minus 5. So in order to get the y-intercept, we will evaluate f of 0. So which means that we have 2 times 0 minus 5, which is equal to 0 minus 5, which is equal to negative 5. So this means that the y-intercept is 0 comma negative 5. Now for the x-intercept, we will be equating the function f of x to 0, and then we solve for x. So in this case, transposing negative 5, we get 2x equals 5, and then dividing both sides by 2, we get x is equal to 5 over 2. So which means that the x-intercept is 5 over 2 comma 0. So this is just a simple example of showing the intercepts of a function, but in the discussion of the types of function, we shall incorporate the intercepts of those types of functions. So this ends the video about intervals where the function is increasing and decreasing, and about the intercepts of the function. So I hope that you learned something from this video, and I hope that you will subscribe to my channel. Thank you for listening.